take Earth and squeeze it down to the size of a peanut. That's how much squeezing you need to do to turn our planet into a black hole. Okay? Now, take the entire known universe, 2 trillion galaxies, every star, every planet, every black hole, every quasar, every speck of dust, and you then squeeze it all down until it's smaller than a proton. Now you've got yourself a singularity. The kind of singularity that was the beginning of our universe. Then that's where you're headed. The moment before the Big Bang. That's the Big Bang, the beginning of everything. But wait, what if it wasn't the beginning? Well, only one way to find out. In this video, we're sending you to the time before the Big Bang so that you can witness the time before any time or space actually existed. Because there's more to this story, a lot more. But if you're going to travel to before the beginning of everything, well, where would you even go? Well, let's see. Where did the Big Bang actually happen? Well, logically, that would be the center of the universe, right? Well, wrong. It's a little complicated, but bear with me here. The thing is, the Big Bang didn't happen at a single specific point in space. It happened everywhere all at once. This singularity you're about to visit isn't really in space. It is space. Before this tiny proton-sized dot exploded, there was no space and no time. All space and time were inside this incredibly tiny singularity. Still follow me? Yeah? Well, this wasn't an explosion in space. This was an explosion of space. As wild as it sounds, our universe doesn't have a center. Everything is moving away from everything else all at once equally. Every place is equally a center. And yet there is no center. All that means is you can't travel to where it happened. You have to travel back to when it happened. To get to the Big Bang, you'd have to go back in time, 13.8 billion years into the past. You'd be traveling in space and time, and maybe even in other dimensions. Things are going to get weird. Starting on Earth today, you'll be the first ever time traveler. And as you traveled back, you'd notice that space wouldn't just get younger. It would get smaller. The distance between galaxies would shrink. This is a classic rewind. Everything would be getting closer and closer together. Stars wouldn't just streak past you. They would unexplode. You'd watch supernovas suck their debris back in to become giant stars. Galaxies would unspin and disperse. Clumps of matter would disintegrate into space dust. And black holes would shoot matter and energy out and then disappear. You'd be traveling back through a fog of space dust. And that dust would get denser and hotter until even the building blocks of our world, the atoms of hydrogen, wouldn't be able to hold together anymore. Now, you're getting close. It would be a claustrophobic experience. Hot, dense, dark. The pressure and temperatures would become so high that it's hard to imagine. It would be just like if you were on an Earth that's being crushed down to the size of a peanut, only 1 billion times worse. You know? That reminds me of how AI is changing our world right now. From just a simple text model in 2019, AI has evolved. And in 2026, it's going to be at its peak. And if you still haven't learned how to adapt to this new world, well, you're in luck, because with Outskull, you can catch up with everything happening in AI in just 2 days. Outskill is the first ever AI-focused educational platform that compresses years of knowledge into an exclusive 2-day AI mastermind workshop. 16 hours packed with content on 10+ AI tools, prompt engineering, workflow automation, and building AI products. No code required. This AI training has helped over 10 million AI professionals worldwide, and it's rated 4.9 out of 5 on Trustpilot. It's happening this weekend, Saturday and Sunday, from 10 a.m. to 7 p.m. Eastern. And right now is the perfect moment to join, because you can get in absolutely free as part of their New Year Upskilling Fest. You'll learn how to build AI agents, automate workflows, and use AI to save hours and gain ready-to-use AI systems for your job, business, or freelance projects. But learning those skills isn't enough. The most important part is knowing how to monetize them. Outskills learners have launched AI-powered services that bring in $2,000 to $3,000 every week. And to kickstart your year, you also get premium lifetime access to over 5,000 professionals, a seamless dashboard, and structured bonuses. A $5,100 value like the AI Prompt Bible, the AI Profit Roadmap, your personal AI Toolkit Builder, and the 2026 AI Survival Handbook. As seats are limited, so grab yours now in the link in the description, and don't forget to join the WhatsApp community to stay updated before the big blast. Now, speaking of blasts, you'd feel a pressure that wouldn't be pushing on your skin. That pressure would be pushing on your atoms and breaking the bonds that hold matter together. Pressure would be so great that even the incredibly strong forces holding your atoms together wouldn't be able to resist it. They'd be ripped apart into the particles that make up protons and neutrons, turned into a trillion-degree fiery soup of plasma. And buckle up, because things are going to get even stranger and maybe even harder to comprehend. Because by the time you reach the point in time before the Big Bang, well, technically there wouldn't be any space or even time. You'd just exist outside of it. You and this tiny singularity. Now, even if there were space and time, you couldn't survive in that environment. Nothing could. You'd be dissolved into the soupy plasma before you even got close. Of course, we wouldn't leave you floating here as plasma soup. For you to experience this most intense time in the history of the universe, you'd need to be in your human shape. And while it's impossible for you to exist at the same time as this singularity, well, we're going to ignore that and, give you the full-on Big Bang experience. Okay, now that you're at the time before the universe's creation, you'd be in a weird space. I mean, not even space at all, because it hasn't been created yet. Okay, let's take a step back. How do we even know this? Well, that's easy. We know our universe is expanding because scientists have observed everything moving away from each other. And as distant galaxies move away from us, there's a red shift in the light they emit. This is called the Doppler effect. It's like if you were standing on the sidewalk and an ambulance drove past with its sirens on. As it zooms towards you, the pitch of the siren would sound high and sharp, and then the second the ambulance passes and keeps moving away, the pitch drops into a low groan. Well, that happens because sound waves are being physically affected by the motion. When sound moves toward you, it catches up to the waves it's emitting, kind of squishing them together. Shorter waves make a higher pitch, but when sound moves away, it's also pulling away from those waves, stretching them out. And those longer sound waves make a lower pitch. Well, light works the same way. When we look at distant galaxies moving away from us, their light is shifted toward longer wavelengths, which is the red end of the spectrum. We call this red shift, and scientists observe that red shift, and that's how they know the universe is expanding. So logically, if everything in the universe is moving away from everything else, well, it must have come from a single point somewhere. That somewhere was once packed tightly together in one single spot, and then exploded outward, creating the expanding universe we see today. That's the Big Bang. Our universe has been expanding for billions of years, which makes the Big Bang one massive explosion of energy. It was an event so big that we can detect the echo of all this energy all around us even 14 billion years later. It's called the cosmic microwave background, the CMBB. But it's not actually a leftover of the Big Bang. The CMBB is the imprint of an event 380,000 years after the Big Bang. So, what happened 380,000 years after the Big Bang? Well, you're going to have to wait a little longer to find out. Right now, it's 13.8 billion years ago. It's just you and the very hot, very dense singularity. You wouldn't even be able to see this singularity because the human eye can't see protons. And the singularity is protons sized. A single proton is 1.7 femtometers in diameter. Yeah, it's unbelievably small. If you looked at the diameter of a single strand of your hair, well, that's 30 billion times thicker than one proton. The width of your hair is to a proton what the entire planet Earth is to a grain of sand on the beach, and it would be incredibly hot around there. And by hot, I mean hot. The core of our sun is 15 million degrees C. In Kelvin, that's 15,273 degrees. The singularity was 10 to the power of 32 Kelvin. That's a 1 with 32 zero after it. Comparing the sun to the Big Bang, though, is like comparing a flashlight to a supernova. At 1032 Kelvin, energy is so intense that individual particles can't even exist. So yeah, it would be unimaginably hot. Lucky for you in this video, not only were you able to maintain your human form instead of collapsing into plasma soup, but you'll also somehow be able to withstand the immense temperature. Imagine that. You're still going to feel uncomfortable. Well, outside of you and the singularity, there's nothing to see here until, of course, the main event in history, the Big Bang. This expansion of the proton-sized singularity happened super fast. How fast? Well, we say in the blink of an eye to describe fast, but the average human eye blink is between 100 and 400 milliseconds. That's fast, but the inflation before the Big Bang happened was something like 10 to the power of minus 33 seconds, which is a fraction of time so tiny that there are more of these fractions in a single second than all of the seconds that have happened in the last 13 billion years. So there wouldn't be any waiting around for the Big Bang. It would be instantaneous and loud. Well, how loud would the creation of the entire universe be? Well, let's see. Space, as we know, is a vacuum, and sound waves need a medium to travel through, like air. But there wasn't any air in space at the moment of the Big Bang, right? So, it must just be silent. Well, no. The cool thing about the early universe is that it wasn't a vacuum yet. 1 full second after the Big Bang, the universe was an evenly dense plasma like a thick hot soup around 10 billion degrees C. But this soup wasn't perfectly smooth. It had lumps in it. And in the chaos of the first second, tiny pockets of this energy were packed just a little too tight. And in these spots, gravity instantly crushed the energy, creating primordial black holes. Now, these weren't the black holes that we know today. They weren't born from dying stars because, well, stars wouldn't exist for another 100 to 200 million years. These were ancient tiny monsters born from the pure crushing pressure of the Big Bang itself. Some might have been as small as an atom, but with the mass of a mountain. And while many of them may have evaporated by now, scientists think there could still be some out there hiding as dark matter. Now, because the universe was a soup and not a vacuum, sound waves did travel through it. These early sound waves, called baryon acoustic oscillations, were deep resonant hums compressing the plasma, and they started almost immediately, just 1 second after the Big Bang. The entire universe was already ringing, but your human ear couldn't register this sound. You'd feel the pressure, but hear nothing. Now, even though the sound of the Big Bang was too deep for your human ears, if you pitched the waves up with a computer, it would sound like static or a deep roar. Now, you couldn't hear the Big Bang, but could you see it? What did the most epic explosion of space look like? Well, the Big Bang wasn't bright yellow or orange like a nuclear explosion. The very first light from the Big Bang was high-energy gamma rays, but those are invisible to the human eye. The universe started as a color you can't see, but then became peach and then black. Yeah. As the universe expanded, it cooled and changed its colors. Okay. Now, remember the 380,000-year point after the Big Bang that we said we'd get back to, the kind of event that we see in the cosmic microwave background? Well, that was actually the point where the early universe finally cooled down enough that you could actually see something. For the first 380,000 years, the universe was opaque. The light from the Big Bang created a fog that you couldn't see through. Photons and light particles were constantly bouncing off free electrons. Light couldn't travel in a straight line. The early universe was a photon fluid. It would be like being inside a cloud or a dense fog bank. Yeah. The Big Bang was so hot it took that long for the universe to cool to a point where light was able to travel in a straight line. The CMB is a snapshot of that exact moment. 380,000 years in, the universe was a warm, bright orange color, kind of like a warm white light bulb in your dining room. Eventually, it faded to red and then black as it cooled even more. Today's universe has a beigey tan average color. Scientists even gave this color a pretty name, cosmic latte. But back 380,000 years after the Big Bang, the CMBB left an imprint that you could still see today in an old analog TV of all places. About 1% of the static that you see on that kind of TV, but that snowy noise in between the channels, it's actually interference from the CMBB. Pretty cool. Okay, if you've made it this far, stick around. It's just another 200 million years before the first stars form. Gas and dust clump up, and slowly gravity pulls in enough matter to create huge stars. These first stars were so huge that they wouldn't last very long before burning out, and they exploded into incredible supernovae. Up until this point, the universe was made up of hydrogen and helium. It didn't have any heavy elements yet, but deep in the centers of these massive first stars, carbon, oxygen, nitrogen, and iron, all the elements that make up your body, were created. And if you're patient and you want to stick around for another 400 million years, you'll see the first galaxies forming. And after waiting a whopping 9.3 billion years following the Big Bang, you'd see our sun form out of a cloud of gas and dust. Okay, you're almost home. Another 4.6 billion years, and you're back to where you started. That's today. And you'd be back to observe what clued scientists into the Big Bang in the first place, the expanding universe. Fun fact, not only is our universe expanding, it's also speeding up. And it's not just expanding because of that Big Bang explosion 13.8 billion years ago. At some point, it started to expand quicker. And it's not stopping. Clearly, something is driving that expansion, but we don't know what. The Big Bang was the beginning of everything. Space, time, the entire universe, and the planet you live on. Technically, the matter that makes up you is energy that existed at the singularity, your recycled Big Bang debris. But what if I told you that wasn't the beginning? What if there was something before the Big Bang? There are a lot of competing theories out there, but one thing astrophysics can agree on is that the universe came from a hot, dense state. That would be that proton-sized singularity. But there are other theories about what existed before the Big Bang, before the singularity, like the Big Bounce theory. The Big Bounce imagines that the universe is constantly expanding, but then collapsing back in on itself and exploding outward again. So, the Big Bang is a result of a collapse of a previous universe falling into itself and bouncing back, a process that repeats itself forever. Now, a different theory called cosmic inflation. Not what's happening to your wallet, speculates that just before the Big Bang, space expanded at an incredible speed. We're talking many times the speed of light, and in a fraction of a second. Then it stopped. The enormous energy that was driving this expansion was transformed into matter and light, creating the hot, dense plasma that was the Big Bang. Some scientists take this theory even further, proposing eternal inflation, which is what it kind of seems like down here on Earth. Imagine that this sheet of expanding space is always expanding, and there are only patches of it here and there that become unstable and stop creating a universe. Well, if this were true, it would create an infinite number of universes or multiverses, and our universe would just be one of many. If the universe is getting bigger, it must be growing into some larger empty space like a bubble filling a room. But it doesn't expand into anything. It's creating the room as it grows. If you flew to the very edge of the universe and looked out the window, you wouldn't see anything, not even blackness. Beyond the edge of the universe, there's no space for light to travel through. It's like a video game map loading. If before the map loads, that void isn't a place you can walk, it just doesn't exist for you to walk in yet. But maybe there's a different explanation. Maybe there is something beyond the edge of the universe. Maybe our universe and everything in it exists inside a very large, very massive black hole. Well, that's a story for another Mystery Atlas.